This is the second video of a series on straight line. The first video looked at gradient. This video will also use gradient to establish the equation of a straight line, gradient m, where it hits the y-axis at the point 0c. This was also looked at in the simultaneous equations videos with a graphical solution where we plotted straight lines. So for example, here we've got y equals x. The equation tells you the relationship between the x and y coordinates of any point on the line. So this is simply saying the y coordinate is the same as the x coordinate. So if x coordinate is -2, the y coordinate is -2, and so on. So it goes through points like 0, 0, 1, 1, 2, 2, and so on. So that's the relationship between the x and the y coordinates. Here's a chosen set of x coordinates and their corresponding y coordinates. If we plot the points, -2, -2, -1, -1, 0, 0, and so on, the line is a straight line. Any point on that black line there fits the description, the y coordinate equals the x coordinate. Here's another line. It says the y coordinate is twice the x coordinate. So if the x coordinate is -2, the y coordinate is twice that, which is -4. X coordinate -1, y coordinate is twice that, and so on. So we're doubling up the x coordinates, multiplying them by 2 to fit the description y equals 2x. Plot these points, -2, -4, -1, -2, 0, 0, 1, 2, 2, 4, etc. The line is a straight line. And any point on that black line will fit the description, the y coordinate is twice the x coordinate. If I look at the gradient of this line between 2 points, for 1 on the horizontal you got 2 on the vertical. The gradient is vertical over horizontal, the gradient's 2. That line has gradient 2. It's as you expect. If you go 1 on the x, it tells you in the equation y is twice x. So 1 on the x gives you 2 on the y. That results in gradient being 2. So everywhere on that line, between any pair of points, for 1 on the horizontal, you rise 2 on the vertical. That gradient 2 comes from the y equals 2x. It comes from the y coordinate being twice the x coordinate. So the y component here is twice the x component. So that makes the 2 on the vertical that gives you the gradient 2. So here's another case, y equals a half x. That means y is half the x coordinate. So I picked even numbers for the x coordinates. And basically, the y coordinate is simply halving -4, halving -2, halving 0, halving 2, and so on. So there the y coordinates are half the x coordinates. Plot the points. There's -4, -2, -2, -1, 0, 0, 2, 1, etc. Plot the points, the line is a straight line. Every point on this black line fits the description, the y coordinate is half the x coordinate. If I look at the gradient between 2 points, for a 1 on the vertical, it's a 2 on the horizontal. That's what you expect. For 2 on the horizontal, the y is to be half the x. So 2 on the horizontal, half that is 1 in the vertical. So that gradient being a half, 1 over 2, comes from the half x here. Y equals a half x, half is the gradient. It results from the equation. So the gradient of half comes from the equation being y equals a half x. So here's y equals -2x. That is, you take the x coordinates and you multiply by -2, and it gives you the y coordinates. -6 multiplied by -2 is +12. -5 multiplied by -2 is +10, and so on. You multiply 0 by -2, you get 0. You multiply 1 by -2, you get -2. That set of points, -6, 12, there it is. -5, 10, -4, 8, and so on. The line is a straight line. And every point on that black line fits the description. The y coordinate is -2 times the x coordinate. If you look at the gradient, it's 2 in the vertical for -1 in the horizontal. It's going 1 to the left. Everywhere in that line, the gradient's 2 over -1. Gradient's -2. As you expect, this says take the x coordinate and multiply it by -2. So if the x component here is -1, if you multiply it by -2, you get +2. That makes the gradient 2 over -1. This -2 results in the gradient being -2. So, in general, we've got y equals mx, where m is the gradient. So the number in front of x gave you the gradient. Y equals x, that line, y equals 1x, has gradient 1. Y equals 2x, that line has gradient 2. Everywhere in that line, for 1 in the horizontal, it's 2 in the vertical. Y equals 4x, gradient 4. Y equals a half x, gradient a half. Notice when you go 1 in the vertical, it's 2 in the horizontal. That's y equals a quarter x, so the gradient's 1/4. So in general, y equals mx, m is a gradient. Gradient a quarter, gradient a half, gradient 1, gradient 2, gradient 4. And there's y equals -x. Gradient's -1. For -1 on the horizontal, it's 1 in the vertical. You do vertical over horizontal, it's 1 over -1. So that's gradient -1. That's gradient -2. -1 in the horizontal, 2 in the vertical. Gradient -4. Gradient -1/2. Gradient -1/4. So that's the general result, y equals mx. You can look at it here in this piece of software. There's y equals x. The gradient is 1, 1. There's some of the points it goes through. It goes through the origin 0, 0. It goes through the point 1, 1. Simply the y and the x coordinate are the same. The gradient's 1. If I make the gradient 2 there, it becomes y equals 2x. It goes through 0, 0 and 1, 2. If I was to look at the gradient formula from the first video, it's the y difference over the x difference. 2 minus 0 on the top, 1 minus 0 on the bottom. That gives you gradient 2. There's gradient 3, goes through 1, 3 here. Y difference over x difference. Gradient 3 from y equals 3x. Gradient 4 when it's y equals 4x. Here's gradient a half. 1 over 2. Y equals a half x. There's gradient 2/3. 2 over 3, and it's y equals 2/3 x. There's the coordinates working out using the gradient formula. The gradient. So, it should be obvious if it goes, this is a line passing through the origin 0, 0, that the gradient is simply the number in front of x. If it's y equals 4/3 x, the gradient's 4/3. If it goes into negatives, so that's gradient -2/5. There's a line, 2 in the vertical, but it's -5 in the horizontal. So, general result, y equals mx. This is the second part. This is adding a number on the end, y equals x plus 4. So take the x coordinate and add 4. -2, add 4, you get +2. -1, add 4, you get 3. 0, add 4. 1, add 4, so on. So we take the x coordinates and we give them an extra 4. Plot the points, -2, 2, -1, 3, 0, 4, etc. The line is a straight line. Oops. Missed a point, there it is. So, that's a line y equals x plus 4. There it is. Every point in that black line fits the description. The y coordinate is the x coordinate, add 4. If you think of y equals x, what it looked like, the points on y equals x have simply been shifted 4 units up. They've been given that extra 4. They go 4 up. Every point goes 4 up. So it's the same gradient as y equals x, but the points have been shifted 4 up. So because it's y equals 1x, the gradient's 1. Because of this plus 4, every point's moved 4 up. In particular, y equals x went through the origin 0, 0. 4 up, and the line here goes through 0, 4. That plus 4 means instead of going through the origin, it's going through 0, 4. 0, 4. So if you make x 0 in the equation, out comes 4. That 4 is the y-intercept. So plus 4 here, it hits the y-axis 4 units up. The y-intercept is 4. Now you can do this in general. There's y equals x. That's y equals x plus 3. Everything's shifted 3 units up. Goes through 0, 3 here. 6 units up. Goes through 0, 6. 9 units up. Goes through 0, 9 here. 3 units down. Goes through 0, negative 3 here. So if you look on the numbers at the end here, plus 9 goes through 0, 9. Plus 6 goes through 0, 6. Plus 3 goes through 0, 3. Minus 3 here in the end, it goes through 0, negative 3. 0, minus 3. So that red number on the end is a y-intercept. Y-intercept 9, y-intercept 6, y-intercept 3, and it's this plus c on the end. So that plus c on the end here, that plus c, that's the bit in red. So here's y equals 2x plus c. So there's y equals 2x plus 5. You think of the old y equals 2x, gradient 2, shift these points 5 units up for that plus 5. So it goes through 0, 0 here, it's now going through 0, 5. That's a line y equals 2x plus 5. It's a line y equals 2x slid 5 units up the way. And now it goes through 0, 5. But it's got the same gradient. These two lines are parallel. They're both gradient 2. So that set of points in y equals 2x plus 5 came from the points in y equals 2x, all shifted 5 up. So there's y equals 2x. There's y equals 2x plus 5. It's now 5 up. There's y equals 2x plus 10. It's now shifted 10 units up. There's y equals 2x minus 4. It's shifted 4 units down. These numbers in red on the end. So there's the plus 10 on the end, it goes through 0, 10. There's plus 5 in the end, it goes through 0, 5. There's minus 4 in the end, it goes through 0, negative 4. Here's y equals negative x. Plus 4 means shift it 4 units up. Plus 8 means shift it 8 units up. Minus 4 means shift it 4 units down. Plus 8 in the end, there's the 8. Plus 4 in the end, there's the 4. Minus 4 in the end, there's a minus 4. So that's the plus c part. And there's y equals negative 2x. Shift it 5 units up for y equals negative 2x plus 5. 10 units up for y equals negative 2x plus 10. Or 4 units down for y equals negative 2x minus 4. They've all got gradient negative 2. They're all parallel, same gradient. But where they hit the y-axis changes. So they hit the y-axis at that red number on the end. That's it brought together. So here we have the gradient is the number in front of x. That was from the first bit we looked at. Gradient can be given by the gradient formula using the coordinates. And this plus c on the end is where the line hits the y-axis, c units up. That's referred to as a y-intercept. So that's it in general. Look at this line here, y equals 3/4 x. If I shift that line 1 unit up, so it now goes through 0, 1. it's just resulted in this plus 1 on the end, but the gradient hasn't changed from being 3/4. Y difference 4 minus 1, x difference 4 minus 0. So there's a parallel line, same gradient, 3/4. It's now hitting down here at B, 0, -2. There's the -2 on the end. So where it hits the y-axis is when x is 0. When x is 0, 3/4 x becomes 0, and out comes that -2. So that's the general form of a straight line. Y equals mx+c. M's the gradient. The y difference over the x difference when it comes to the coordinates. That's the gradient formula from the first video. And all I've got extra is this plus c on the end, where it hits the y-axis, 0, c. So this is what you expect to be able to do. You're shown a line, you should be able to get its equation. What you look for is the gradient and the y-intercept. Well, the y-intercept's easiest to get. It hits there at 0, 5, c is 5. The gradient, taking 2 points in the line here, just spaced them a bit further apart so it's easy to see on the slide. 6 on the vertical, 3 on the horizontal. Vertical over horizontal is the gradient. Gradient's now 2, m becomes 2, c is at 5, y equals mx+c is the general form. Replace m by 2 and c by 5. The equation of that line is y equals 2x plus 5. That means if you've got an x coordinate, so let's say the x coordinate was 3, double it and add 5 is 11. It should go through 3, 11. 3 along. If you count up here, that's 11 units up. That's the point 3, 11. If x is 0, y should be 5. Make x 0, 2 nothings. Add 5 is 5. So this gives the rule to connect the x and y coordinates of any point in the line. It's the form y equals mx+c, that's the form you have to know. And the m's the gradient and c is the y-intercept. Second example, for this one, it's hitting down here at 0, -2. So c is -2. The gradient, take a little step in the line. 6 in the vertical here, 2 in the horizontal. Gradient 6 over 2, so the gradient's 3. Replace m by 3 and c by that -2, and that's the equation of the line, y equals 3x minus 2. Every point in that line, if you put an x coordinate in, multiply it with 3 and subtract 2, you'll get the y coordinate. And this one, again, y equals mx+c, c is easy to get, it's hitting here the y-axis, 3 up, c is 3. Gradient, look for a little step in the line, 3 in the vertical here, 6 in the horizontal, vertical over horizontal, 3 over 6, a half. M becomes a half, c is 3, that's the equation of the line, y equals a half x plus 3. Here's a case with a negative gradient. It's hitting here at 0, 2, so the y-intercept is 2, c is 2. Gradient, 6 on the vertical here, and it's -4 on the horizontal. 6 over -4 is -3 over 2. M becomes -3 over 2, and the c is at 2. That's the equation of the line. One exception is vertical and horizontal. So every line, y equals mx+c, except vertical and horizontal. So this position here, 4, 0, if I make the condition x must equal 4, x coordinate must be 4, every point where the x coordinate has to be 4 is on a line here, 4, 0, 4, 1, 4, 2, 4, 3, and so on, 4, -2, 4, -3. As long as the x coordinate is 4, that's the condition. Well, anywhere on this line has x coordinate 4. That line has equation x equals 4. Just says every x coordinate is 4, y can be anything. This one here, x is to be -5, so -5, 0, -5, 1, -5, 2, and so on. As long as x is -5, it's going to lie somewhere on this line. So that line has equation x equals negative 5. A vertical line equation, x equals a number, a constant. So that's x equals for a vertical. Horizontal, y's got to equal a. The y coordinate must be a. 8, 0. Sorry, 0, 8. So that's 0, 8, 1, 8, 2, 8, 3, 8, 4, 8, and so on. Negative 1, 8, negative 2, 8, as long as it's something 8. So the y coordinate's always 8. A horizontal line. Every point on that black line, the y coordinate's 8. Here, y is to be negative 2. So 0, negative 2, 1, negative 2, 2, negative 2, so on. Everywhere on this line, the y coordinate's negative 2. Horizontal line. So a horizontal line, y equals a constant, y equals a number. So that's the exceptions to y equals mx plus c. If you've got a vertical line, it's x equals a number. If you've got a horizontal line, it's y equals a number. And all you need to know is some point in the line, like here, 4, 1. Then if it's a vertical line through 4, 1, it's x equals 4. If it's a horizontal line through, let's say, 1, 8, horizontal line through 1, 8, it's y equals 8. So vertical x equals horizontal y equals every other line, y equals mx plus c. Now to deal with y equals mx plus c, if you click the link in the description, there's a worksheet. It'll have the answers with it. The idea is you look at the graph here, you look for the y-intercept and you get the gradient of the line, and using y equals mx plus c you write the equation of the line. So this PDF from the first video had a gradient exercise with answers. That was in the first video. It also has this exercise, 16 questions to get the equation of the line, and it's got the answers with it. The next video will look at the straight line where you don't have the y-intercept. So cases like this, the line passes through 2 points. You have to get the equation of the line, but you don't have the y-intercept. Hope you found this video useful. Thank you.